We will now talk about Amazon SageMaker, which helps automate and standardize MLOps practices across your organization. SageMaker pipelines are a fully managed feature that helps you automate and orchestrate different steps of the ML workflow, including data loading, data transformation, bias detection, model building, training, and evaluation. Process massive amounts of training data and build and retain models at any scale. Share and reuse workflows to recreate or optimize models to scale ML across your organization. SageMaker projects bring CI/CD practices to ML, such as maintaining parity between development and production environments, source and version control, automate testing, end-to-end automation. These help you standardize ML deployment process and accelerate model deployment from days to minutes. Many customers train hundreds of models for a given use case, each with multiple versions. Tracking these models and their versions and the associated metadata is critical for repeatability and discoverability to enable model reuse and meet compliance requirements. With the SageMaker model registry, you can track model versions, their metadata such as use case grouping and model performance metrics baselines in a central repository, where it is easy to choose the right model for deployment based on your business requirements. Model registry automatically logs the approval workflows for audit and compliance. SageMaker logs every step of your workflow, creating an audit trail of model artifacts such as training data, platform configurations, model parameters, and learning gradients. Use audit trails to recreate models to debug potential issues and help support compliance requirements. SageMaker Model Monitor, which also detects model drift, concept drift in models deployed in production in real time, is now integrated with SageMaker pipelines and SageMaker Model Registry, allowing you to automatically schedule model monitoring as part of CI/CD. This allows you to automate the task of maintaining the quality of model predictions in production. SageMaker offers a comprehensive set of security features, including infrastructure security, data protection, authorization, authentication, monitoring, and auditability to help your organization with security requirements that may apply to ML workflows. Use SageMaker, you can standardize security policies across the entire ML development process to increase your security posture and reduce the time it takes to provide data scientists with access to the data they need while complying with your organization's data security requirements. Now that we have gone through the significant challenges and how SageMaker helps overcome them, I would like to spend a minute summarizing the value of SageMaker brings to your business and present to you what we are talking about. So we are talking about operational challenges with managing ML lifecycle. ML lifecycle is an iterative process where data scientists first prepare the data using different data transformations and then build, train, and deploy models. These manual steps can slow down data scientists since building even a single model requires experimentation with thousands of iterations to arrive at right model parameters. Even after a model is deployed in production, the accuracy of ML models can deteriorate over time, a phenomena known as model drift we have talked about. Many factors can cause model drift, such as change in model features. The accuracy of ML models can also be affected by concept drift, the difference between data used to train models and data used during inference. When these occur, the model needs to be retrained. These model building is not a one and done task, and manual steps can delay on innovation and waste data scientist time. With a growing number of models, these manual processes get amplified and hinder ML adoption process across the organization. In addition, as the number of models and models versions grow, it becomes difficult for data scientists to trace back to training data used and model artifacts when issues come up in model predictions. Lastly, data scientists cannot collaborate with each other without repeatable experiments and lineage tracking. And similar to deploying software updates, deploying ML model updates requires CI/CD practices. This is to avoid downtime during deployment and to benchmark the performance of models in production environments. But software CI/CD tools cannot handle ML model updates since ML involve both data and code. As a result, MLOps engineers have to write custom code to build CI/CD for ML. Regulations such as Equal Credit Opportunity Act or the Fairness in Housing Act may require companies to be able to explain financial decisions and take steps around model risk management. Meeting these requirements require building custom security and governance solutions, which can take months or even years.